Excuse me, Miss Lopez. Miss Lopez, can you please keep it down back there?
I'm very sorry.
Thank you.
Would you like me to leave?
Maybe. All right, thanks to all of you for showing up and filling up this great auditorium. This is going to be a good set of presentations. We did lose one. Kirk Zerang had a family medical emergency and had to stay in Louisiana this week. So we'll miss him, but we still have 3 great presentations that we're looking forward to. This session is using visualization to improve society and inform decisions, something that all visualizations should do in some way, shape, or form. Our first presenter is Dr. Ross Wang. He's going to be talking about visualizing inequality and mobility using National Household Travel Survey data in New York State. Dr. Ross Wang is an R&D staff of the Oak Ridge National Laboratory. He's one of the key members of several national transportation data programs, including the National Household Travel Survey and the Freight Analysis Framework. He's currently developing a web-based data analytics and visualization tool for the National Household Transportation Survey add-on users. Dr. Ross Wang.
Good morning, and thank you, Michael, for the introduction. I'm glad we have like a full room pack of people. Yeah, I actually was interested in that workshop too, but hey, here we are. Hope my presentation will show some different view to using the National Household Travel Survey data. I would like to acknowledge my co-authors who contributed to this study. This is not a funded research, so it's kind of like a side study that we did. So it's I'm just showing the preliminary results right now. So what I'll be talking about is general give an introduction of what people have been talking about or existing studies of inequality, and mostly I'll be talking about measuring inequality using Gini Coefficient. It's a coefficient that's used for primarily looking at income inequality in the world. And then we'll be applying Gini Coefficient in trying to use that to evaluate mobility inequality. And I'll be giving a brief introduction of the National Household Travel Survey and the data, and then I'll show some preliminary results of what we got in terms of inequality of mobility by different demographic and socio-economic characteristics. So just a brief introduction. There are some studies that I've done on mobility and inequality, and most of them looked at things like accessibility to transportation. But in some, it is important to recognize that inequality has arisen as a result of the complex set of interactions between transportation and land use patterns. And that said, in some, it's a complicated question, and people try different ways to quantify or try to evaluate the inequality. So our attempt here is to use a National Household Travel Survey data, but use a simple coefficient trying to hopefully show some different views to that. Just want to point out, studies suggest that essential services become distant. So like hospitals or like a shopping center, food accessibilities become distant. So people need to travel more, but then different income levels, education and gender and ethnicity and vehicle ownership actually affects how people's ability to travel. So that's where the inequality occurs. So on the right-hand side, I'm showing 2 charts, just showing you some ideas of what I mean. So on the top, it's the x-axis is the education attainment. So the higher the number is, the higher education you get. Number 5 is graduate school or above. Number 1 is without high school degree, I think. So if you look at that, and the y-axis is the number of person miles traveled. So as you can see, it seems like a higher educational level, you're actually traveling longer distance. And similarly, on the bottom, it's same thing for the y-axis, but the x-axis is household income level. So the higher the number it is, the higher the income you're getting. So you can see that if you're looking at the total miles traveled, you can see the higher income you're getting, it seems like you're traveling more. So what does it mean to have higher per person miles traveled? It means that you're using more, you consume more energy, right? So that in the sense of that, you're actually using more of the resources of the world. And most of the mobility measures used are person miles traveled and trip duration. So that's the things that we'll be looking into later in the study. And talking about the Gini coefficient, that's a coefficient that's used in economics to measure deviation of wealth, or usually income distribution from equality. So what it does is it plots it plots a curve. It's called Lorenz curve. What it does is that on the x-axis is the population, the cumulative population. So if you sort your data, if you're a data person, if you sort your data based on income levels, so from lowest income to highest income, right? And then I keep pressing the wrong button. So and then you look at the cumulative proportion of your population as your x-axis, while you plot the cumulative income level as the y-axis. So unit is from 0 to 1 on both axes. So if the curve, so that line is a perfect equality, that means where you are in terms of the population is also where you are in terms of income. So if there's an area that's enclosed, that means there's inequality, which means the later population, the higher end population also accounts more of the income. I hope that makes sense. So to calculate Gini index, it's basically calculating the area of the orange area divided by the total triangle. So A plus B is is at the bottom, and then A is at the top. So a perfect equality, you will have A equals to 0. Okay, so a Gini index of 0 means it's equal. Whereas if a Gini index equals to 1, which the whole triangle is basically the orange area, which only occurs when the richest people has all the money of the world. And that's usually doesn't happen. But that's kind of how this index is defined. This index has been widely used for income levels, but it has also been used for looking at educational inequality. So educational levels, you sort your population based on educational level, and then you plot it based on the cumulative proportion of population and the cumulative proportion of education. And also look at health in terms of infant death rate, for example, and use for sports in terms of the competitiveness of teams and how equal that is, making the league be. So on the bottom here, it's showing inequality of income in the world, and it's the map is basically color-coded based on the Gini index, and I apologize for using red and green. I know it's not good for colorblind. That's why I need to go to that workshop. But the green means it's more equal. The red means it's less equal. So you can see in some of the South American countries and African countries, the inequality is more obvious. So it gives you the good thing about using Gini index is it gives you a relativity, right? It's not what's the GMP per person. or what's the GNP for the country, but it's giving you some kind of relativity in terms of how equal it is. And that's assuming it's a perfect world. But I guess my point is it's a good, simple way to compare. Now, so the objective of this study is to define and compute Gini coefficients or indexes for measuring and visualizing inequality in mobility. And specifically, we're using the data set from National Household Travel Survey data with a focus on the New York State data set, which is an add-on data. So just show of hands, how many of you have never heard of National Household Travel Survey? Okay, well, still some, great. So National Household Travel Survey is a national data set, national survey that's conducted usually anywhere between 5 to 8 years. And right now it's conducted by the Federal Highway Administration. So the goal of that survey is to understand how people travel and how frequent they travel, what kind of mode they use, how many miles they travel, what's their demographic information, like in terms of gender, education level, their age, their household income, things like that. So it's giving the government a overview of the daily travel conducted by the US population. And it includes all the modes in terms of cars, transit, bike pad, and there's some information there in the data set. Includes the information of the person itself, himself or herself, the household situation, and the vehicle information as well. And it's the authoritative national data that's been used a lot for travel behavior studies, and it's used by agencies like MPOs and state DOTs for transportation planning purposes. It started in 1969, and it was called NHTS back then, and then the names changed. And the survey format changed as well along with the years, but it was named, the name changed to NHTS in 2001. The data set that we'll be using is 2017. So Oak Ridge National Lab's role in this is we are actually hosting the data on the nhts.ornl.gov website. And starting in early 2000s, we started to not only provide the data, but also develop tools that people can use to quickly get a glance of what the data looks like. So we're providing things like frequently used statistics like vehicles and person trips and person miles, and summarized by different demographic information. So just give you an overview of what the data contains. The national data set has, the survey was conducted to 26,000 family households for the national data set. And then agencies can actually pay more and then get more samples for their jurisdiction, so they have a better picture of what their the people travel in their jurisdiction. So there were about 100,000 add-on households, and then which total consists of almost 1 million trips that's been surveyed. The specific data set that we're using today is it's a New York State data set. New York State is one of the add-on agencies, New York State DOT. There's about 15,000 households, which is about 120,000 trips that we're looking at today. I'll be giving another presentation later today specifically on the tool development that we did for add-on agencies. So I guess I'll make a little bit of advertisement here. So feel free to come by this afternoon and hear more. And that's kind of a screenshot of what we're developing right now for add-on agencies, which consists of data analytics, extraction, visualization, and some aspects, something related to those. So like I said, we were trying to use Gini coefficients to quantify or try to evaluate mobility inequality. So what we're looking at is the mobility attributes that we're looking at are PMT, or person miles traveled, and trip duration. So the idea is that, like we see earlier, it seems like the more income you have, you tend to travel more. So miles travel is kind of a quick abstract way of seeing how much people are traveling. So if you, for example, if you have low income, very likely you will not be able to make a lot of the social leisure travels versus if you have higher income. So we think it's appropriate to use PMT as one of the attributes to evaluate inequality. And the other one is trip duration. So the assumption is that you tend to spend more time if you cannot, for example, if you cannot afford a car, you will be taking transit. And most of the transit system will require longer travel time. So that's something that we think we will look into as well. So in the meantime, we're also using some socioeconomic attributes, including income and education. So as a exploratory analysis, because I believe this is the first time we try to use National Household Travel Survey data to look at these aspects. And the characteristics that we're using include household location, vehicle ownership, ethnicity, age, gender, and trip characteristics. And I'll talk more in the following slides. So again, this is the Gini index, and it's calculated based on this curve. So we'll be doing that. So just a very broad overview of what these may look like. So I'm showing 4 graphs here. Includes, on the left is the household income, and then educational attainment, person miles traveled, and also travel duration in terms of minutes. So this gives you an overview. So this is like the whole data set. We only get one index for each items that we're looking at. So this doesn't give you relative sense of what that means, but I'll just warm us up with this, just a few numbers. So I'm going to show more complicated plots now. So what we showed before was the overall numbers, right? So, but if we break it down by ethnicity, for example, then we'll get 5, if there are 5 races that we're looking at, we'll get 5 numbers for each items that we're looking at. So for household income, we'll get those curves, and then same thing for the others. So I'm showing 5 curves for each category, but on the bottom, I'm summarizing the first 3 races in terms of being white, black, or Asian. If you look at the numbers, the smaller the number, it means that's the Gini coefficients, right? So the smaller the number means that the more equal it is. So when the number goes higher, that means there's higher inequality. And we're speaking in relative terms, but it provides an information within the same category. So for example, if you look at household income, the orange line here is white. Okay, the gold or yellow, dark yellow line here is black. And there's green somewhere here, that's Asian. So you can see that judging from the curve itself, you can see white people's curve is closer to the ideal equality line, versus black, it's further down. So that means there's higher inequality in black population than the white population. That doesn't mean white people are making more money or black people are making more money. It's just showing a relative equality situation. So it's not saying that white people is better than black people in this regard, and vice versa. And then for educational level, we're also seeing a similar trend that white people seem to have more equality in education versus black and Asian people. One thing I would like to point out is PMT, the person miles traveled. You can see a huge difference between white people and black people, and the number is 0.7. Gini index is 0.7 for black population, which means there's higher inequality when we slice the data based on ethnicity, specifically to the black population. In terms of travel duration, there's not much difference that's shown among the three populations that we're looking at. So we further divide the data into essential and non-essential trips. And what that means is essential trips are basically work-related trips. You're doing business, or you are going to school, where you are, you have medical trips that you need to make. So those are kind of essential trips. The non-essential trips are social trips, leisure trips, and shopping, things like that. So there's not much difference except for the person miles traveled again. So the non-essential trips show higher inequality, which means some people travel a lot non-essential trips compared to some people that just cannot afford to travel those trips. All right, I think I have 25 seconds left. So I'm going to get into, so we can also calculate an index and then plot it based on the geography of your household, right? So this is some preliminary results that we're getting. This slide's showing, based on your household location, what's the income equality or inequality. So this is New York State, and those are the counties. And you can see the darker color means there's higher inequality. Now, we haven't done a lot in terms of trying to explain what these numbers means and what may have caused this, but right now I'm just showing you some preliminary results in terms of what we've seen so far. And on the right-hand side is the MPO levels. So I think there are about 15 MPOs in New York State. On the bottom right is a NEMEC, which is New York City metropolitan area. So this slide shows the income inequality. And then we also did the same thing for education inequality. And you can see that, for example, in New York City, it seems like it's not very unequal in the sense. But again, we haven't really looked into the detailed numbers and trying to figure out what that really means. But I'm simply presenting some of the results that we're getting. In terms of PMT, and you can see that New York City or the whole metropolitan area is showing higher inequality in terms of the miles traveled and travel duration as well. So, all right, a quick summary. We use Gini coefficients for mobility inequality to explore the idea of how this simple index can help us just quickly see what's going on, and maybe with more in-depth study, we can communicate with stakeholders and counties and MPOs and say, hey, this is what we found, and maybe we can discuss more and see what's going on, or helping them to make planning decisions based on these. And it's showing that there are some differences that we see in race, in trip characteristics, in terms of whether or not the trip is essential or not, and also vehicle ownership. I think I skipped that slide, but vehicle ownership has a lot of effect on the PMT travel. So if you own a car, it's more equal, I guess. If you don't own a car, the equality, the Gini index is higher. So this provides a means to assess inequality among different geographic locations. And like I said earlier, this is preliminary, so we're hoping that we can conduct more in-depth studies and to shine more lights to this, the use of this. So with that, I would like to thank you for your attention, and I'll take questions.
Yes, thank you.
Thank you.
We do have time for questions if anyone wants to ask one. You don't have to approach the mic if you want to yell, yes.
Thank you for the presentation. So basically, about an eighth of your data set was from travel think you can extrapolate your results to other states?
Thank you. Thank you for your question. Yes, I was going to do that. So his question is, can we use the same method or extrapolate based on this to other states instead of just New York? And the answer is yes. So what we were focusing on was New York, but then we can also apply to larger scale, for example, the National Travel Survey data. We can use the whole National Travel Survey data, and we can look at so instead of county level, we'll be looking at state level. So we can compare the indexes based on the state level. And any other survey, so there's a limitation to any data set, really. So depending on your data set, like yesterday, a student from MIT, she was showing the Singapore household survey data. And it seems to me that they have more granularity in terms of data and the coordinates, the geographic coordinates of the respondents. So that's going to be helpful for some further studies down to a finer area, for example, census tract level. So it's, but the short answer is yes, you can apply it to a larger scale or a smaller scale depending on your data set.
All right, thank you again.
Thank you. Thank you, appreciate it.